Hello, everyone. This is Ted Baldry with EasyPower, and I want to welcome everybody to the EasyPower webinar series, and I thank you for attending. I'm sitting in for Jim today, who's in Atlanta doing an arc flash presentation there yesterday and today. And I want to kind of get started. What I'm going to do, start out with a poll, and then I'll introduce the presenters as we get going. To begin with, let me switch to, these are going to be the two poll questions. Which equipment presents incident energy mitigation problems for you, and which method for arc flash hazard risk reduction seems appropriate for your hot work at your facility? So let me launch the first one. These questions just help us to kind of gauge the audience a little bit and see where the audience stands. We'll give it just another minute or so. Okay, maybe just another 10 seconds. Thanks for taking the time to do the polls. Okay, it looks like the majority is the low voltage MCCs and switchgear. Let me switch to the second question. Okay, here's the results. This one is a little closer. Let me switch here. Okay, I'm going to just introduce our first presenter. I'm actually going to introduce both presenters. The first one is Erhan Cokal, and he's going to be presenting first, and then we'll switch to Jeff Miller. I'm just going to kind of give the introduction to both of them, and then once Erhan is presenting, Jeff will do part of it as well. So Erhan Cokal received a Master's of Science in Engineering from METU in 1996. He then joined Schneider Electric Turkey as an R&D engineer. Erhan joined Square D Company Engineering Services team as a power systems engineer in February 2006, focusing on arc flash mitigation and selective coordination for critical facilities. He's currently working as an offer marketing leader for low voltage power distribution systems based in Nashville, Tennessee. And Erhan is a member of the IEEE. He's also a registered professional engineer in the state of Texas. And Jeff Miller is a specifier consulting engineer and channel segment programs for contractors and panel builders. He ensures that customers have an experience that is beneficial to solving customer challenges and giving them the tools to be more effective, knowledgeable, and competitive. He provides strategic planning, sales force enablement, business development, marketing, digital customer experience, and program execution in the specifier segment across all business units. He also leads a team providing channel programs and launch support for specifiers, contractors, and panel builders. And he's a great voice of the customer with past experience as a consulting engineer, control system integrator, electrical contractor, and electrical utility engineer. He's very experienced with water, waste management market, with additional experience in commercial buildings, healthcare, and industrial. And we appreciate both of them taking time to do this presentation today. And I'm going to switch the presentation over to Erhan, and we'll go from there.
Thank you. Arc flash incidents can happen, we know that, and it can happen anytime and to anyone who is working with energized equipment. The end result can be costly and tragic, with damaged equipment, personal injuries, or even death. So today we will talk about all these items and the new method, how we can address arc flash issues. There are several arc flash incident energy mitigation solutions available. So the questions we must ask during the early stage of the system design what's the suitable method for your system? And how can we minimize the risk of hazard at its source in an economical way? These are two important questions we should ask, and we should try to find answers early stage of our design. Dr. Parsons raised a great question during IEEE electrical safety workshop. A few months ago, I attended that workshop and addressing what's the sufficient isolation in between line side and load side of an electrical enclosure. As you can see from my slide, IEEE 1584 recommends using an upstream device for calculations if the line side isolation is questionable. So this situation requires engineering judgment or having a certification from the manufacturer in order to decide whether your main breaker is sufficiently isolated. Otherwise, as a system study engineer for a long time, I will probably consider labeling the equipment based on the worst case scenario to protect employee who is working for that equipment, right? We will address all these concerns in this presentation with a new technology called arc block. Before that, my coworker Jeff will continue and just introduce our codes and standards. Jeff?
Thank you, Erhan. Just to give a little review, I want to talk about the two primary electrical hazards. The first one being electrical shock. I'm sure we're all familiar with that. The risks have been managed for over a century now. Typically, they were ID'd by voltage, so they were well known, and we use things like tools and PPE to help manage those risks. A lot of times, electrical shock occurred from unintentional contact, whether it be energized parts, tools, enclosures if grounding wasn't working, or even media like liquid, like rain, water, inadvertent times. A lot of times we can mitigate these hazards pretty easily with design, insulation, or barriers, or grounding of those items. But it only takes a low level of current to cause electrical shock. So there are about 30,000 reported non-fatal shocks per year, which is likely a low number compared to non-reported shock. So we've all been shocked. One of the things about being shocked is well, the levels and intensity of shock is it only takes a really low current to shock somebody. Usually around 10 milliamps is where it starts getting painful, and around 100 milliamps, which is still pretty low, is when fatalities start occurring. Before that occurs, you're going to get things like paralysis, severe shock, hard to breathe, even uncontrollable muscles, stuff like that. So this person hanging on the pole there, could easily not have a fatal shock, but die from falling. The other one that, has come about probably from the 90s that we started gain precedence is arc flash and arc blast. Commonly just usually referred to as arc flash, but there's two different ways the energy is released. So basically an arc flash blast occurs when there's a sudden release of energy, mainly due to current passing through copper being ionized as a gas or plasma, and the vaporization of that copper. That can cause some extreme things to happen. One, the heat tends to be around 35,000 or up to 35,000 degrees Fahrenheit, which is hotter than the sun. The other one is that, copper, when it goes from a solid to vapor, expands 67,000 times, which can cause a lot of pressure, the release of a lot of contaminants and projectiles. It is an explosion. Also intense light and shrapnel and sound waves, molten metal. These are all things that can lead to a fatality. And we knew there were a lot of accidents that happened with these, but until around 2002, when we started to take action with standards being developed or putting into existing standards like NFPA 70E, which requires workers to reduce these hazards and have risk control methods. Yeah. So NFPA 70E has a hierarchy of risk control methods, starting at the top with being the most effective, and with elimination, and going down to the bottom, which would be PPE. And you might be looking at this chart going, PPE at the bottom, that kind of surprises me. But the idea behind this is that we want to remove workers, who are involved with the hazard from taking actions. So if we can eliminate that, that's at the highest point of being the most effective. That would be, establishing an electrically safe work condition so that as they're working on equipment, they're removed from the hazard. Now, this is usually a temporary state, so this, we can't continue to disconnect from the source. If we look at another very effective method, engineering controls, and this is where we're reducing the risk without worker involvement, by doing things like GFCI, barriers, doing designs that may encapsulate the energy, reduce the amount of energy released, but and it's less likely to be affected by human error, which as we go down to the more least effective methods, that tends to occur. But if we look at the amount of arc flash accidents that have happened in the last several years, I want to give credit due to those least effective methods. It's awareness, administrative controls, PPE improvements, and the use of them that has really brought about a reduction in those accidents. A little bit about our solution that Erhan had talked about earlier. The arc block solution, is basically looking at an engineering control where we're not involving the worker so that we lower the risk. And it's also a passive control, as you'll see later on, compared to an active one. So even less room for human error. So in 2017, there were about 134 fatalities due to arc flash in the US. That's roughly about 3 a week. And if we think about it, that's an unacceptable number, knowing the hazards and being able to mitigate them. Also, there are about 10 to 15 people hospitalized every day with arc flash burns. It only takes a 3rd-degree burn for somebody to be hospitalized and be in serious condition. And when you get over 25% of the surface area of your skin, that generally results in fatality. And that is easily caused when you're exposed to a high amount of energy released in an arc flash blast. And therefore, it's very important that we take this hazard very seriously and we try to mitigate it. I'd like to take a second to watch this quick video. Now, obviously, if you were standing in front of that, you'd be in big trouble. Even without PPE, you'd probably have a fatal accident. With PPE, you'd still be severely hurt. Not only that, if this was a critical facility, you're not returning to operation anytime soon. So there are some controls out there that protect personnel, whether it be PPE or arc-resistant gear. But it's also important when we need to realize there are times when we have to also protect the equipment itself so that we can get back to operation as quickly as possible. I'd like to take a look at a couple of codes and standards and examples of how we can reduce those risks. The current edition of the AAC is 2017, and there are several things discussed concerning arc flash and shock. Right now, I'm going to concentrate on barriers. We already know that the first starting being mentioned earlier in the 2000s, and then it started referring to 70E, and then it started talking about labeling. But coming in 2020, which is really soon to be released, there's going to be a new requirement for service entrance barriers. Now, this requirement basically is, to prevent inadvertent contact with a high energy source, the line side of equipment. But it doesn't do much to really protect the equipment itself. It's mainly personnel protection. And we are really looking here in this picture to the right, goes above and beyond that. You also find other barriers, requirements for panel board, switchboards, and switchgear in NEC 408. I'm not going to get into that. That's existing in the code. So NFPA 70E basically goes over safety-related concepts for electricity. And between releases, they have an annex. So 70E is usually not adopted, but referred to. OSHA has a clause that basically says it's an acceptable standard to mitigate the hazards. Therefore, a lot of people, refer to this standard within a facility or the International Brotherhood of Electrical Workers. Looking at, this language right here is probably going to be adopted in the next version in 2021. And it's looking at, how do we reduce the energy released, that's available to damage equipment and to harm personnel. So we can see here, and Erhan will get into the specifics, that basically most of your energy is going to be on the line side. Once we get past the breaker in the picture there, we're going to have significant energy reduction. So if an accident occurs on the line side, that's where a lot of the hazard is, and reducing that by encapsulation is basically an acceptable method for doing that, and reducing both shock and arc flash. With that being said, Erhan, take it away.
Thank you, Jeff. Thank you. Yeah, it's a good introduction for electrical hazard control and how standards and codes are telling us what we have to do. And now let's see what's happening in a system level. Jeff slightly mentioned about that. Here is a typical case study, right? Just like service entrance application. On the left, we see a one line of 1,000 kVA 480 volt system, including the utility transformer and the utility transformer protective device. In this case, it's a fuse and a downstream switchboard. We have two zones, the line side of the main breaker, which is zone 1, and the load side of the main breaker, which is the zone 2 with green color. For this example, the incident energy for the line side, based on the calculation, 15.6 on the line side, and the 1.6 calorie per centimeter square on the load side. So the difference is essentially, the difference is coming from calculations, because the upstream protective device on the line side is the utility fuse, and the downstream is protected by 1200 amp main breaker. So as we can see from the elevation drawing in the middle, it's the same enclosure, the same lineup, but we have two different arc flash incident energy levels. So on the next slide, we are seeing the same case study, exactly the same case study with the square D arc block. Arc block reduces the arc flash incident energy on the line side. As you can see here, the enclosure line side arc flash incident energy level is reduced less than 4 calorie per centimeter square. It's not 90%, they are less than 1.2 calorie per centimeter square, but it's just PP1. For that reason, we are saying 4 calorie per centimeter square. This is done by an innovative arc energy reducing passive system with safety by design approach. So it's completely aligning with, like Jeff mentioned about in his presentation, NFPA 70E's requirements. So here is the structure of the arc block line side isolation system. This is a passive system, like arc resistant type of structure. So the first picture shows the arc resistant shell. In order to contain the arc inside of the enclosure, right? In the middle, after removing the pressure cover, the yellow cover, we can see the interior containing the cables. These covers, they are metal sheet and some thermoset material, and they are completely surrounding the locks for reliable separation. It's the reference to Jeff's presentation for barriers required in NEC and NFPA 70 codes and standards. And it's just completely separating face to face and face to ground. The question is, that's good. This is good for shock hazard that Jeff mentioned about in his presentation. What about arc flash protection? How we can mitigate the arc flash incident energy level? Here is the magic of arc block technology. So arc block can reliably clear an arc. This is the difference of arc block from traditional arc resistant system. It acts like a breaker, actually, and it clears the arc in a few milliseconds. Our research and development engineers are inspired from a circuit breaker technology. Then our system architect, Mr. Tim Faber, applied the same technology on the line side power conductor section. During the arcing period, we control where the arc can go. So arc behavior is just calculated, and like it happens in the circuit breaker technology. And while we know where arc will go, we can maintain the arcing voltage by stretching the arc. At the same time, we can cool it naturally. So that's the technology, which is pretty simple but effective. This is also called stretching, cooling, and exhausting type of system, right? So even though we interrupt the arc quickly, less than one cycle, there is still some significant energy inside of the arc block. Basically, it's just 1.2 calorie per centimeter square, which is pretty high actually. So we need to keep this energy separated from the user and not to let to go load side, right? So to do this, we have added some special features to the arc block shell, acting like explosion-proof switch. This system will not allow any plasma or arc transfer from load to line or line to load side. So here's a quick animation to show how does it work, what's inside of the arc block module, including a visualization of the arc development. Actually, you can see from phase A to phase B, the arc is going to initiate. This is solely exaggerated animation, right? Just it's not going to happen such dramatic, and it's not showing how arc is cool it down and exhausted. So it's just giving an idea with this animation how we are stretching the arc. And finally, it's just like I would like to show a real-time video. This is a comparison of traditional MCC with the arc block MCC. It's tested in our Cedar Rapids labs when you all witnessed, and it's just showing the real case. So this is a traditional MCC upper incoming cable connection, and we are seeing 480 volt, 100 kA, and 100 milliseconds, both cases. See, it's even difficult to recognize this is side by side, and it's even really difficult to see the effect in arc block case. It's the same parameters used for the test, and the arc block is clearing the fault significantly fast. So, after a short description of the arc block technology, I would like to summarize how we come to this idea as a company, manufacturer. So, selection of arc flash mitigation methods is a challenging task for many facilities, right? Our preliminary research and customer surveys show that a simple, reliable, and affordable design are the expectations from us as a manufacturer. We did lots of research with users. In order to achieve this challenging task, you may ask yourself some critical questions in the early stage of the system design. For instance, first question, in my opinion, how can I reduce the risk, right? That's the first question. And then, what's my goal? PPE2, PPE4, or mixed in an entire system? Which operations do I need a PPE? Maintenance or troubleshooting? Is service continuity or equipment damage a concern for my system and process? What's my budget to achieve the goal? You know, this cost is important. And is there any restriction for additional construction like exhaust plenums, etc.? You are designing your system in an early stage, and if you don't know those answers, it's going to be more costly to mitigate the arc flash incident energy level in the system, right? So the answers to these questions and more probably will shape the system design. Our arc block technology redefined the equipment construction to play an important role for the system design, right? And the personal and equipment protection in the early stage. It will also make the selection of the arc flash reduction methods easier for everybody like system designers or arc flash study engineers, for everybody. Here are some recommendations I would like to share while selecting arc flash mitigation techniques for your system, just to consider it. First of all, you need to reduce arc flash incident energy level or PPE for any case. And you need to focus on improving your service continuity while doing that. And you need to reduce exposure to live pods as much as possible. You need to specify an equipment with safety by design approaches, right? Exposure to live pods is minimized. And also, this is very critical. Jeff mentioned about in his speech, 80% of the accidents, they are due to due to us. So simplified commissioning and usage is going to certainly reduce the human risk factor. So just simple system is the best system for the arc flash incident energy hazard control. And also, you need to optimize the costs for CapEx and OpEx perspective. And of course, you need to save the space with minimum footprint and less construction. So in the next slides, I just use what does arc flash do in a system level, right? We talk about in a product level, how does it work, what does it do, but in a system level, how will it help our problem? So arc block line side isolation technology. It's a passive system. Many available solutions focus on actively removing the arcing fault after it begins on the load side. If we consider NEC's methods or just available techniques we know, they mainly focusing on load side, and then they are removing the arcing fault after it begins on the load side, right? On the other hand, arc block technology reduces the likelihood of an arc flash incident on the line side, which is usually the worst case scenario from the arc flash calculations. However, arc flash incidents still can happen, right? For example, humidity and environmental conditions may be on the one of the root causes, right? Just there is a term for that one. During the weekend, just you are leaving your equipment, and during that period of time, due to humidity, dew, or some other reasons, the arc flash incident can happen on Monday morning where you energize. So it still happens. So if it happens, this innovative technology also reduces the arc flash incident energy level significantly, around 1.2 calorie per centimeter square. In other words, it's a system to minimize the human risk factor and reduces the arc flash incident energy level. So here are the technical features of Square D Model 6 MCC, which is available now. It's up to 1200 amp and will be expanded for higher amperages in 2020. It's available for up to 100 kA withstand current at 480 volt. It is tested per NC IEEE standard and UL witnessed. It's the standard footprint. In other words, you know, this arc block edition will keep the same small footprint with the standard MCC. Here is the IEEE research graph showing the source of the equipment in the distribution system causing injuries. And thank you for the everybody just answered the poll question. You guys, you all know the answer. You know, MCC is one of the most trouble causing equipment in the distribution lineup, right? It's the second highest source of incidents, according to this research. So in the field, operators are more engaged with MCC than any other low voltage distribution equipment. For that reason, we started our design with Model 6 MCC. However, this new innovative technology will be expanded for switchgear, switchboard, and the other equipment in the distribution line. PPE is an important part of a safety program. We know that. On the diagram graph Jeff showed, it's the last line of defense. It's described by NFPA 70 as the last line of defense, but it's still important, right? It should be as comfortable as possible for efficient work practices. I personally myself dressed up PPE4 for a job in Texas. It's causing some other problems while you are trying to protect yourself. So still you need to use PPE for sure, but it should be as comfortable and providing flexibility to you. So engineering controls with product design will help reduce the magnitude of the hazard. So considering this fact, in addition to arc plug main feature, we added some supplementary feature, right? Just like to minimize the exposure of employee to energized parts. So let's see all those augmented features now, and it will just going to help us. As you can see from the first picture, this is a traditional IR scanning. On the right, with the arc block technology, you are seeing another way of thermal scanning. Thermal scanning is important. 25% of major electrical failures are due to loose connections or faulty connections, right? Thermal monitoring is important, but whenever you are performing your thermal monitoring, you need to get exposed to energized part, or you need to use IR scanning window, which is causing some other problems because of small angle you can reach to check the connections. So let's remember the engineering controls chart, right? That mentioned NFPA 70 is one of the most effective ways the engineering control, right? We added thermal sensors inside of the arc block vault, so that minimizes the risk of exposure to the energized part. So that's just, you are designing your equipment considering safety. So that's the main philosophy of arc block technology with Square D Model 6 MCC. And on the next slide, I'm going to talk about our thermal sensors we integrated into our arc block enclosure so that it will minimize the exposure to energized part. This is also a good example of preventive maintenance in a safer way, right? You have a continuous thermal monitoring rather than once a year. And you can record all those information, and you can early engage with possible failure in your system. You can see the temperature rising, and then you can say, hey, something is going on, and you can do preventive maintenance. Our thermal sensors, TH110, it's a wireless sensor and do not require any batteries, actually. It's energized using a 10 amp of current in the circuit. It is located on the main locks. I can show from the video here of the main breaker terminals, and it will provide the continuous thermal monitoring data. So you may connect it to your SCADA system or locally monitor the temperature rise. The other technology we added is absence of voltage tester. In a traditional way, you need to get exposed to energized part, and we thought on the load side, after locking out, tagging out your main breaker, you need to do absence of voltage testing. This is a system, it requires no exposure to energized part. As you can see on the picture, employee can easily check the absence of voltage in the Model 6 MCC. So here are some benefits of the arc block technology. Actually, these can increase when you see in your application some challenges, right? But these are what we collected from the field. First of all, it's a passive system, so it's always on. There isn't any human interaction to turn it on or forget to turn it off. It doesn't require any commissioning or field testing. It has the same life cycle with the equipment, with proper maintenance, right? So this is a big advantage, and also it also provides a benefit of commonly used virtual main application. In other words, arc block is a barrier, it's a block in between the dangerous line side and the load side by reducing the arc flash incident energy level significantly. And as a third item, arc block clears the arcing fault as independent from the upstream protective device. An available fault current, actually. So it controls the unknown changes in the system. As far as I know, some facilities, they do require every 5 years some arc flash study renewal. It's because of those changes, right? So arc block can help that one. So arc block is also fast enough to clear the fault. So your upstream protective device may not trip. The fault is clear and service can continue. This is a huge advantage, right? Just it acts like a medium voltage recloser. So it's just an analogy. So your system on the line side, there is an arc fault, it clears and it can continue. There is no service interruption. It is reliable because it's a passive system and there isn't any need for settings, commissionings, etc. It's always over there. It reduces the risk of exposure to energized part with the special volt section. And as different than traditional arc resistant equipment, it reduces the arc energy at the same time containing the minimal amount of arc energy. So the released gas is very minimal, not to use any exhaust plenums. You don't need to worry about any construction or additional construction or higher footprint. And finally, it will certainly simplify the engineering judgment, because in the field you are just thinking, hey, is this equipment is sufficiently barrier system on the line side. If study engineers, they don't know this, they will focus on the worst case scenario, right? And they will consider the line side arc flash incident energy, and they will label the equipment based on the worst case scenario. And that's the final of my presentation. But before that, I have a quick video here to show, and I'd like to share that one to summarize everything in general.
Surge in electrical equipment. It is an extremely dangerous and life-threatening event. To address this, the National Fire Protection Association has implemented arc flash protection standards, NFPA 70E, and the National Electrical Code, Section 240.87. These standards define work practices to safeguard employees from injury while exposed to electrical hazards. But the fundamental challenge remains: what more can we know to move arc flash mitigation work practices to engineering controls, thereby reducing the likelihood of recurrence or the severity of an arc flash? You can look to Schneider Electric, manufacturer of the Square D brand of electrical distribution equipment, for the latest innovative solutions. The new patented Square D arc block technology used on motor control centers brings a new level of performance to arc flash mitigation. This passive system provides arc isolation for the most dangerous area in the lineup, the line side conductors. Arcs are less likely to occur. If they do, they are continued.
All right. And any questions, please let us know. All right, I can see some questions. What's the price premium for this arc block MCC compared to typical MCC and arc resistant? Certainly it's lower than arc resistant, and please connect with our your local Square D representative, and they will certainly answer that question for you. And I can see another question: is arc block available now? Yes, it is available for Model 6 Square D Model 6 MCC, and it's going to be expanded for higher amperages into 2020 for the 2500 amp and higher, and then it's going to be expanded for switchboard and switchgear as well. And there's another really good question: can arc block be retrofitted? Yes, the answer is yes. It is going to be retrofitted for Square D Model 6 MCC, but also it can be used as a virtual main, remote main, to protect the line side of other lineups. So that's the answer for this question. And another same question: is arc block only available for MCCs today? Yes. Is Square D the only one currently using this method? Yes, but so it can be, it's a patented technology. So it's the Square D's new innovative technology. The name of the temperature sensing sensor is TH110, EasyPower TH110. There are some other sensors for temperature rise testing. So EasyPower TH110 is Schneider Electric brand sensor. The other question is AVT available now? Can it be retrofitted? Yes, it is available, and it can be retrofitted with a 3-inch bracket for your Model 6 MCC. You can order as a 3-inch bracket, and then you can install your existing MCC. Another similar question. Another one. And I am seeing some more other questions related with what I answered. And if there is no more other question, I am going to give some references to check and to understand more. Please continue to extend your questions, and we will be happy to answer all of them in our arc block main landing webpage. There's an option over there for your questions, and it will be certainly answered in 24 hours. So we have also Proficient Premier Access portal for engineers, designers, and specifiers. Jeff, would you like to add for this portal a few sentences before closing the webinar?
Sure. I'm always glad to give a plug for the portal. So the portal has a lot of good tools for engineers and information. Some of it's not available on the rest of our website. One of the really nice things is that we organize a lot of the material specifically for consulting engineers and specifiers and designers, so that we put it all in one place for you. The other thing is we have a nice specification library where we have guide specs that we specifically put in a engineering perspective versus a manufacturer perspective. And the third thing I'd like to mention is our learning management system, which if you go into the portal and hit training, there is a lot of online training available to watch on demand. Not only the webinars we normally produce, but also a lot of e-learning and curriculums that we've developed throughout the years. Everything from power to building systems to EcoStructure power, and even some fundamentals for young engineers, and even some soft skills will be on there.
All right, thank you so much, and thank you for participating. We appreciate, and have a great day. Thank you.
Thanks, Erhan. Appreciate it.